Hi everyone, again welcome to the incredible learning experience Jnana Learning. We are continuing the lecture on electromagnetics and it is lecture 5 Gauss's law. So if you are watching the video for the first time, please do subscribe our channel. So Gauss's law, which is one of the fundamental laws of electromagnetism. So what's Gauss's law? It states that the total electric flux, which is represented as psi, through any closed surface is equal to the total charge enclosed by that surface. Clear? That is, the total electric flux through any closed surface is equal to the total charge enclosed by that surface. We can represent it as psi is equal to Q enclosed. Psi is the electric flux and Q is a charge enclosed by that particular surface. Now see, psi, which we can write as closed integral over d psi, which is equal to closed integral over the surface d dot ds. What is d? It is the electric flux density. So we can write psi, that is the electric flux, is equal to closed integral over s d dot ds. Now see the total charge enclosed Q, which we can write as integral rho v dv. What is rho v? It is the volume charge density. So rho v dv, integral rho v dv is equal to Q. So we have an equation for psi is equal to integral s d dot ds and Q is equal to integral rho v dv. Now see, we are equating these two equations, that is charge Q is equal to integral over s d dot ds, which is equal to volume integral rho v dv. This is under the it is a volume integral, this is a surface integral. We have psi is equal to Q, so we can equate these two equations, that is integral s d dot ds and integral rho v dv. Now see here, so we have Q is equal to integral s d dot ds, which is equal to integral of v rho v dv. Now we are applying divergence theorem to the middle term in this equation. So we have already studied the divergence theorem. It is a theorem relating the surface integral and volume integral. So we have integral s d dot ds is equal to volume integral del dot d dv. So for more details, you have to refer the divergence theorem. That is, we are applying divergence theorem to the middle term of this particular equation. So we have closed integral over s d dot ds is equal to volume integral del dot d dv. Now see, we have two equations. Here is the volume integral and here we have another volume integral. We have to equate these two terms. Clear? So here it is rho v dv and here it is del dot d dv. So we are equating these two terms and we have rho v is equal to del dot d, and this is the first form of Maxwell's equation. So it states that the volume charge density rho v is the same as the divergence of electric flux density. Del dot d is a divergence of electric flux density. So it states that the volume charge density is the same as the divergence of electric flux density. Now Gauss's law, it is an alternative statement of Coulomb's law. It is a proper application of divergence theorem to the Coulomb's law results in Gauss's law, and it provides an easy means of finding E or D for some symmetrical charge or infinite line charge, infinite cylindrical surface charge, or a spherical distribution of charge. Like that, it have got immense application for this Gauss's law that we will discuss in another class. So this is the Gauss's law.